Everyone, and welcome back to the 2023 CINR webinars. Before we get started, I just wanted to make sure to remind participants that the overviews you are going to hear during this session are intended to introduce the topic area and subtopical areas, provide context about the types of ongoing work that's happening in the Office of Nuclear Energy's programs in relevant technical areas, and provide guidance on areas that are clearly outside of the NE mission space. The presentations and Q&A are intended to inform the applicants that you may choose to submit to this funding opportunity and not to constrain those ideas only to those being pursued by the programs. At the end of all the sessions in the topic area 5, instrumentation and controls, we will have a Q&A session for each of those presentations. With that, we'll turn the time over to our first presenter, which is Patrick Calderoni, and he's going to present on IC1, sensors and instrumentation, as well as IC2, the advanced control systems. Patrick, when you're ready, please go ahead.
Yes, good morning. I am presenting this on behalf of Daniel Nichols, which is the Advanced Sensors and Instrumentation Federal POC. Melissa Bates, which is the Federal Manager for the Higher Program Element, which includes ASI, is a panelist, so I'm sure she will be able to support any questions you may have that are maybe more related to the federal and DOE role rather than the technical portion which I represent. I am the National Technical Director for the ASI program. As such, I'm going to introduce the topics. Next slide, please. Here's a general overview of what the topic area 5 is. The first bullet is general and reminds you that what we are after is solutions that address existing critical gaps. So research and development on sensors, instrumentation controls, and related infrastructure that is necessary to address critical gaps, to monitor and control both existing and advanced reactors. So there should be an awareness of what the gaps are in current technology and addressing those. The other bullets go a bit more in specific of what gaps have been identified, so give you a sense of where this research should be focusing on. So the first bullet relates to the sensor portion, so that's reliable, cost-effective. Both are important things when addressing power systems, and detectors that provide real-time, accurate, and high-resolution measurements. So here are other critical keywords. Real-time means that you collect data from the operating reactor, so during operation. Accurate is that you improve the accuracy with which the data and the measurements are collected, and high resolution, of course, they're related. And so provide higher performance with respect to what existing technology solutions are. And this addresses, as stated before, advanced reactor core, fuel cycle systems, which includes also experiments geared towards the development of new fuel forms, and plant systems outside the core of the nuclear plant. So that's the first part. The second bullet then switches to the control portion of the INC, and so the development of control algorithms that enable real-time control of plant or experimentation process variables, and then enhance reliability, availability, thermal performance, and resilience. All of this geared, of course, towards reducing the cost of electricity. Again, these are gaps in the control space. The next piece is related to communication. So research on communication technology that enable real-time transmission of sufficient data for online monitoring and advanced data analytics flows from the previous two pieces. As the instruments become more advanced, so they also require higher data transmission rates and so forth. And so communication technology need to step up and follow along the enhancement and the technology development. Another gap is the emerging of the machine learning and artificial intelligence capabilities that could be enabled for INC, nuclear INC, and those then would support the development of semi-autonomous operation and maintenance by design, as again for existing plant or advanced reactors. As probably mentioned by other presenters. This year also the INC topics is intending to be as broad as possible to collect all possible contributions. And so we will consider other relevant topics related to INC. Again, and later I will have some disclaimers on what topics are not going to be considered. Next slide. So the first IC1s, the first element here related to the instrumentation piece. Again, it's an easy thing in the title, instrumentation and control that we can. So this is related to the first part, instrumentation. So sensor technology is a bit of repeating, but I'll enhance the message that I said before. Sensor technologies that are focused on existing reactor fleet. Those should address needs which help extend the plant operable lifetime, and provide additional capabilities to increase safety, reliability, and efficiency, which is another way to say cost in terms of the production of electricity. So existing fleet is one element, and advanced reactor concepts and designs is the second element. And these are, should tailor efforts towards accommodating the unique qualities of the future fleet, so the specifics of advanced reactors, some of which are listed. They're not comprehensive, so smaller form factor, small SMRs and microreactors, increased operating temperatures for using coolants other than water, and working fluid compatibility, so both the high temperature and the materials compatibility aspect. So both existing fleet and advanced reactors. A bit more guidelines. The application should identify the type of instrumentation to be developed or enhanced, and should specify the relevant reactor conditions for which their technology is applicable. So the applicant should show an understanding of the target operating conditions, and tailor their proposals towards them, and make a clear case on how the sensors and instruments are going to work in specific radiation field, which includes neutron and gamma, temperature, depending on the reactor design and the fluid, pressure, and working fluid compatibility, if that's applicable. Propose new sensors concepts or leverage existing technology with the intent to enhance capabilities. This goes back to the initial bullets on identifying gaps and move to reduce or minimize the existing gaps. Develop a full instrumentation system, which includes data acquisition capabilities. Most modern technology require an integration of the sensor portion and the interrogation portion. These are not standalone systems, so we're not interested in materials development for sensors. We are interested in a packaged solution for an INC need. Perform a preliminary demonstration of the proposed instrument system under relevant condition during the period of performance. We have kept this as broad as possible, so there has to be demonstration, and then the proposal should build the narrative of why the demonstration plan is relevant. Next slide. Related work, just to provide an indication of what technologies are considered. This comes primarily from the work done under the Advanced Sensor Instrumentation Program, which has many avenues for funding, which include direct research, the NUP work, which we're discussing here, SBIR, STTRs with industry and industry FY. The topics in red here are essentially some of the areas in which we're working on the instrumentation side. I will read through them: neutron flux detectors, acoustic sensors, thermocouples, printed sensors, specific subset of passive sensors, linear variable differential transformer, widely used in irradiation experiments, radiation hardened electronics, and additive manufactured sensors. Again, the usual disclaimer: this is not an exhaustive nor comprehensive list. It's just intended to provide you some information and guidance. And I'm pointing, and I will read it only now. It will become later also in other slides, but that's the website where you can find a lot of resources in terms of the research work that is ongoing or has been completed as part of the ASI program. Next slide. So here, the areas not of interest, which will be repeated for the controls. So I will spend a bit more time now, less later. So these are the areas or applications scopes that are not relevant to this topic would not be considered. Nuclear non-proliferation purposes, technology that are solely related to nuclear fusion applications, such as the plasma portion, personnel dose monitoring, nuclear weapons R&D, nuclear medical scope isotope production, and nuclear medicine related technologies. So again, applications on technology that cross-cut any of this could be considered, but if they are the main scope, the main purpose of the work is to fit in one of these categories, it should be considered for different FOAs. Next slide. Now we go and switch to the second piece of the INC, the controls part. So this relates to the development of or targets the development of semi-autonomous operation, and which has been proposed as a key effort to reduce the cost of next generation of nuclear reactors, the cost of electricity of next generation nuclear reactors. The Office of Nuclear Energy is interested in receiving application in this space, and again, semi-autonomous operation, autonomous, semi-autonomous. There's always so that phase and progression, let's say, to reach is a target to reach. Of course, there's a phased approach to it. Fault-tolerant control systems and enhanced load following and load balancing of multi-unit nuclear power plants, such as SMRs. That's the easier case for this control need. Two necessary important consideration for this is that we will be the coupling of digital twin assets, which is an emerging area and an important tool in terms of the design of advanced reactor systems. And it should incorporate robust cybersecurity into the design. We will have the next topic dedicated to cybersecurity, so we'll make clear to what extent, cybersecurity should be considered as part of the control system. But clearly it needs to take that into account as being important now. The application should identify a realistic control system scenario and that pertains to an advanced reactor. They should develop a control system considering the necessary instrumentation and cybersecurity solutions. And it should demonstrate the control system design with the instruments and the cybersecurity that in a simplified benchtop surrogate. So a demonstration portion should be included in the proposal scope and possibly coupled with a digital twin representation, which is, as I mentioned before, it's becoming an important tool on developing and demonstrating controls capability. Next slide. The topics, so again, to give you an idea of where the ASI program is currently working, again, the iron in red, development of semi-autonomous control system, preliminary development of digital twin applications, online monitoring and diagnostics of system components, and operation and maintenance support provided by artificial intelligence or machine learning solutions. Disclaimers and the ASI website I had already mentioned previously, so we can move to the next slide. The areas not of interest are essentially the same, though here they're target of control, so I will read them again. Those are the not relevant areas: nuclear non-proliferation, technology that are solely intended for nuclear fusion applications, nuclear weapons R&D, and nuclear medicine isotope production. Sorry, next slide. So the next topic will be presented by someone else, and I will come back to close essentially with the last topic.
So let's have Rebecca Onashok. Oh, here, we see you now. Can you
hear me?
Yes, we can hear you. Thank you very much. Go ahead when you're ready.
Fantastic, thank you. Since this is Patrick, I'll talk a little bit to the Office of Nuclear Energy's R&D program that's ongoing in this area, and then to the call and the features that will make applications most successful. We do have a cybersecurity R&D program in the Office of Nuclear Energy. It's a little bit different from some other security type programs you might see, where their focus is on enhancing security, and then maybe figuring out how to reduce the impacts of that. Our mission is very much like the Office of Nuclear Energies, which is about enabling cutting-edge technologies, enabling nuclear energy deployment, improving the efficiency of ongoing operations, and so forth. And we're finding places where cybersecurity enhancements can help make those things happen. Either there's a real perceived barrier to that, or ways where the current approach could be improved on to be more efficient, less costly, and so forth. Our key products are methods to mitigate the cybersecurity hazards during the design, looking at scientific methods for documenting risk, especially ways to help take credit for things during licensing processes, and also looking at some more cutting-edge future scenarios for nuclear where cybersecurity might be a barrier at the moment. And then also looking at some technical tools industry can use, design requirements, supply chain, test beds, and things like that. Next slide, please. As to this call, we are looking for R&D and technologies that can support and enable digital solutions for the nuclear sector. And that's really what this area has said in years past, but we are broadening it very subtly, and I want to make sure it's really clear. In the past, we were very tightly linked to just what our specific R&D program does, which was very focused on safety-related and security-related control systems, NRC licensed control systems applications at the plant. At this point, we are also looking at much more broadly anything that is nuclear-related cybersecurity. It could be advanced technologies and use cases, which I'll get into a little bit in the next slide, solutions to improve economics or effectiveness of the existing fleet, also the future fleet. And then I also want to make it a little bit clear, and I'll try to elaborate as I go through. You've heard cybersecurity mentioned in some other scope areas as well. If you've got something that's kind of on the fence, the difference really is that if you're looking to advance another area, but cybersecurity is a key consideration, say you have an AI application you want to develop, or a control system, digital twin, something like that, cybersecurity can be part of that. It can be a big part of that, but if your ultimate goal is about developing that research area or advancing it, it probably belongs there. Here, we're looking at things that are solving very specific cybersecurity challenges, even if they're very close to one of those. For example, you probably wouldn't be looking at comparing different types of AI for a solution here, but if you understand how to resolve cybersecurity associated with some AI application, it might be here. So hopefully that'll help explain why it appears in both places and what the difference is. The next slide, please. Some of the kinds of things when we talk about advanced technologies and use cases, I'm going to just name some of the things we're thinking of, but this is in no way limiting. As others have said, this year's intent is to be very broad and open-ended and to hear your ideas. But some of the things we've seen are places where people are trying to apply machine learning, digital twins, data analytics tools, and really linking those to the operation of a plant. Some people want to apply cybersecurity analytics tools that are really advanced for attack detection response. Advanced use cases like remotely or autonomously operating a plant, wireless sensors and controls. Some of the things we've not really allowed before that we consider are things like we use advanced manufacturing, or we're looking to, for some advanced plants. And some of those also have cybersecurity implications of how those components come into a plant, integrated energy systems. And the farther away you get from the actual plant, probably the harder it is to going to make something nuclear specific, but we didn't want to limit your thinking on that. So the things still do have to be nuclear specific. For instance, when I talk about advanced manufacturing, we are not going to be looking at, like, if there's some particular advanced manufacturing machine that's used in all sorts of applications and just how to protect that device.
Becky?
Yes.
Your microphone is, it seems like it's a little blocked, or maybe it's far away. We're having a little bit of a hard time being able to hear you.
To check my settings and make sure it's using the right device. Just 1 second. Thank you for letting me know that.
Is this better?
Oh, it's, yep, so much better. Yeah,
I
we can hear you
apologize.
loud and clear now.
It switched to the wrong device. If anybody had trouble hearing something, please bring it up in the Q&A. What I was going to mention is, just as an example, in advanced manufacturing, just as again, these are all random examples, nothing intended to be limiting in what you say or do here in your applications. But if you were to say, I know of a certain type of advanced manufacturing machinery, it's used all over the place, I know how to protect it from cyber attacks, and I want to propose something in that area, it's less likely to be successful than something, for example, saying, hey, we know that nuclear operators are going to be relying on a whole lot of data analytics that went along with this to make their safety case. How could cyber attacks affect the actual safety of a nuclear plant or the regulatory process, or something very nuclear specific about these applications? So next slide. And I'll give examples of strong applications, and then on the next slide, some things we're not looking for. Strong applications here, again, will be very nuclear power specific, not things that are just broadly being addressed for industrial control systems and critical infrastructure protection. There are a lot of other R&D programs in that area. So we're trying to get very nuclear specific. We also think that a good application should really clearly define what is the cybersecurity challenge that will be addressed by the research. And as applicable, if you're looking at adversary behaviors, threat models, and that, be very explicit about what the problem is that's being solved. Also, and it's something that we've seen in the past, so I want to come out and be clear on it, the application should really understand the current state of practice and what the proposed work area is. There's very little in cybersecurity that's starting from ground zero. So understanding what already exists and how the proposed work would make an advance in the context of those things that already exist. I want to be really clear, this does not preclude total blue sky novel ideas where maybe there's not something to compare it to at all, but the need that underlies that research should still be clearly expressed and understood. Next slide. Things that are not of interest is we're generally not looking for attack models, intrusion detection tools, and things that are similar to commercial tools that are already out there. The current industry is using commercial tools. Other critical infrastructure sectors are using them. So that's not to say that this topic area can't be addressed, but a successful application will have to really explain why a new tool makes sense or is needed and offers some real benefit in the context of what already exists. There has to be some kind of a business case for advancing this area. We're also not looking for things that are developing things like high performance computing capabilities, cryptographic algorithms, things that are for general broad purpose use and are not really nuclear specific. I will give quantum computing as an example. We're probably not going to be looking for demonstration of quantum resistant algorithms and things, because that's still very cutting edge and low technology readiness level. It's being researched by other organizations. NIST is looking at that. So there really isn't even a broadly accepted method for doing that. So trying to take things that aren't commonly ready and figuring out how they would be applied nuclear is probably premature. So we're really, again, low TRL things can be considered, but only if there's a really nuclear specific use case and it's not something that's just broadly being investigated in the scientific community. And again, we're also not looking for tools that are broadly applicable to all types of industrial control systems or critical infrastructure that are not nuclear specific. So really that nuclear specific theme is the key to this area, and it's generally not going to be taking something that's otherwise broad and just saying, oh, well, I stuck it in a nuclear plant, so that makes it nuclear specific. You'll have to really identify what the nuclear need is in this area. And that's all I have. Thank you. There's a different presenter for this one.
Patrick, are you still with us?
Yes, turning on the camera, sorry.
Great, thank you.
So this is an easy task, essentially, because it covers all else, the idea in INC. So proposals that are relevant to INC that are described in the topic area 5 overview, but they're not covered by the previous topics, so IC 1 and 2 that I discussed before, can be submitted under the IC4 topic head. It is important to note that any submission here can be cross-cutting, but must reinforce the Office of Nuclear Energy mission and following the overall goal of the office, which I will read just for the sake of completeness: advance nuclear energy science and technology to meet U.S. energy, environmental, and economic needs. So, we have discussed that previously, but I'll restate it. The focus on enabling continued operation of existing plants, the deployment of advanced nuclear reactor, supporting the development of advanced nuclear fuel cycles and fuel forms, and maintain U.S. leaderships in nuclear technology, energy technology. So this essentially collects everything that you may consider or you may think is INC relevant, but does not fit directly into the previous topics. And now I know I've been a lot drier in my presentation than Rebecca has been. So if there's any question related to scope of the supporting programs in this area, now I will be happy to entertain any questions.
Thank you, Patrick, and thank you, Rebecca, for your presentations. Like Patrick mentioned, we do have time for questions related to the work scopes of topic area 5 for Patrick and Rebecca, and you can ask those by typing them into your control panel. So we do have a few questions already, and I'll begin with a grouping of questions for IC1. And the first question is if you have any specifics on detector requirements. So for example, neutron or gamma rays or charged particle detectors.
So I will go back to the comments earlier. So I think the proposal should identify the specific targeted application. So in terms of what the specification could be, there'll be the one related to, again, the application you identify. The application needs to support Office of Nuclear Energy. So I think the topic of so say the more relevant considered topics would relate to neutron flux and gamma flux. Other charged particle are probably not of interest, although again, it depends. It's up to the proposal to make the case that they would be. There is some work related to using other types of particle detectors to control nuclear reactor, but again, it's important that you make that tie, not the development of detectors itself, rather how it's intended to be used to support the nuclear energy office mission. So in short, that answer is obviously neutron and gamma flux are of relevance in conditions that are then specific to either the existing PWRs or that they're specific to design of advanced reactors. And normally the main difference there is related to the temperature in which they are intended to operate.
I believe we also have Melissa Bates here with us who can help answer questions if needed. Melissa, would you like to test your microphone?
Sure. Can you hear me?
It's really muted. Can you get a little closer to it?
Sure. I don't know where the microphone is since I'm using a personal computer. So
That sounds a little better though. Okay. So when you want to jump in and provide additional answers, please go ahead and do so, okay?
sounds good.
Thank you.
Okay, moving on to the next question, and I believe this is IC1 applicable. Is this topic area interested in the development of new detector materials?
Yes, and I specifically called that out previously, so I'm glad this question was put forward. It is, but not as in itself. So I mentioned before, we are interested in collecting a full solution for instrumentation need and towards filling a gap on existing technology. So obviously, the work that we are seeking should be innovative work in nature. And so the development of a new sensor type that depends on a new material would be extremely interesting. Although, as mentioned, so it has to be packaged, so it shouldn't be specifically a materials development task. As mentioned by Rebecca, there are other areas in which this could be covered. But a new material that is packaged within an instrument solution that includes, again, the sensor, the packaging, the data acquisition, and demonstrates the performance of the instrument as a whole, it would definitely be of interest.
Thank you, Patrick. In IC1, is application of artificial intelligence, machine learning concepts to radiation detection data analysis relevant?
Yes, I think this is relevant both to IC1 and IC2. Since we are strongly target and apply, so we want a targeted application to be considered, to be clearly stated. And so radiation detection is important to reactor controls. And so the application of machine learning, artificial intelligence can be considered or could be included in topics of interest, both from the standpoint of improving the performance of existing detectors or from the standpoint of providing new methods for controls. So in this case also, we are seeking for proposals that demonstrate an INC need, not that demonstrate solely the application of machine learning or the development of machine learning or artificial intelligence algorithm. But if you do package and provide a narrative for how the machine learning and artificial intelligence would be used to enhance the performance of the sensor, and to which application is targeted, then yes, they are an interesting piece of the work that can be proposed.
Great. For the same work scope, again, IC1, is the study of radiation effects in advanced semiconductors relevant? And what about studies that focus more on the device level issues? Are those also relevant?
So radiation hardened electronics is part of the development of instrumentation. Unfortunately, I will repeat myself a lot, but this is another situation where the specific aspect has to be put in the context. So there are instruments that do require electronics to be close to the source of radiation. And in this instance, the development of radiation hardened electronics is an important component in order to demonstrate or to define the performance of the instrument. In this case, the effect of radiation on the electronics is an important piece. However, we are not, again, seeking for material development type solutions where the topic itself is addressed as a standalone topic. It needs to be included in the narrative for the development of an instrument that closes a gap on existing technology or improves the performance of instrumentation. And then it needs to be tied back to the application and the targeted application. So identify where such radiation hardened electronics or component for electronics should be developed.
Okay. Another question also for IC1. Does the coupling with digital twin asset imply the use of INL or other specific products? Or does it just mean the use of simulation technology is encouraged?
Definitely the latter. There's no specific relation to any INL developed product or any other laboratory in this sense. It's the broadest term of digital twin, widest application, and actually other industrial applications for the most, right? So definitely the latter.
Okay. And there was a clarification there that was actually geared for IC2. Then the response may be the same.
The response is the same. Yes.
Okay, thank you for that clarification. IC1, are sensor power issues relevant?
Yes, yes, that's an important piece of the sensor performance, both in terms of I don't know where the question is leading, but both in terms of noise, but also in terms of feeds. So, ideally, an improved sensor performance could be that you don't have to power a sensor that's, so it could be self-powered. There's a lot of concepts in this sense that could provide power to a sensor without having to feed it through cables. I don't know where that question is going, but yes, the answer is yes.
Okay, thank you for that. The next question is geared for IC1 and IC4. What is the technology readiness level we should target?
So the nature of this request for proposal is to target innovative work. So I don't want to enter in specific numbers in terms of technology readiness level, but we are looking here at innovative work and providing feasibility demonstration and providing an initial single effect, if you want, demonstration. So in essence, we are targeting low TRL, although the definition of the TRL state can be a rather long conversation. So I would say low TRL as being the answer.
Okay. Can detector dead time for multivariate systems be relevant to these work scopes?
Again, going back to my answer previously, yes, only in as much though as it targets a specific improvement in a detector system in an instrument. So the dead time could be an important element of improving performance. So I guess the answer is yes, but it should be included in a narrative of a specific instrument and a specific application.
Okay, great. Thank you. And is there any comment on the TRL level of the packaged solution?
I think this goes back to where we were before. So this is low TRL. We are not expecting a full demonstration in terms of for testing in a prototypical environment. There is a progression and a phase. The proposal should clarify how it intends to provide a demonstration that is adequate to where the product is in terms of technology readiness. So there should be a clear identification of what type of demonstration is proposed in essence. And it doesn't have to be a high TRL type demonstration, which means either relevant condition but just to provide an example, if the proposal targets an advanced reactor that operates at a specific temperature, the sensor and at specific neutral flux, the sensor can be tested for single effect at temperature without neutral flux, but the materials included in the proposed work should be able to withstand that temperature, right? So it should show the progression and the applicability to the target application to whatever demonstration level fits essentially the researcher intended purposes, capabilities, and so forth. And on this aspect of TRL, if Melissa has any further comment from the standpoint of the federal program, I'd be happy to collect any further feedback.
I don't have anything at this time. Thank you, Patrick.
Okay.
Okay, it looks like we have one more technical question before a few more general questions. So the last one here is, are these work scopes in topic area 5 more geared to advanced reactors?
Well, I'll answer and then I'll have Rebecca answer for cyber. As far as ASI is concerned, the answer is no. At this point, the call was specifically put out broad, and so it also includes the improvement of existing fleet solutions.
And for cybersecurity, the same is true. The difference really being that for the existing fleet, anything that is proposed has to make sense in the context of what already exists in the existing fleet, and there has to be some kind of a business case for why they would consider moving to a new solution if one already exists. So there has to be some innovation there that makes sense.
Okay, thank you both. Now we have some more general questions, and I'll ask those now. One of those asks whether the involvement of the HBCU and minority serving institutions carry weightage in this topic area.
And this is Drew Thomas. I'll answer this question. The review criteria for all areas of the research and development program have what's called a diverse team scoring opportunity or review, and that does take into consideration any impactful collaborations or involvement of minority serving institutions, which include HBCUs.
Okay, thanks, Drew. What is the best way to get information on the existing technology gaps related to the NE mission?
So this is a combination approach, right? Today is intended to give you an overview of what those potential gaps are and what's currently going on in the program that are related to these topic areas, or the programs that are related to these topical areas. There's also several different resources, both in the presentations today, as well as on neup.gov. All funded NEUP projects since 2009 have abstracts listed out on the neup.gov website. You can use the search function in the top right-hand corner to search for any topic areas or any keywords that may come up in those abstracts. Additionally, we are taking care of, we're trying to develop additional opportunities for engagement. Those include, as was mentioned on Tuesday, the concept of having an open engagement or office hours type concept that will allow applicants to take a look at these topic areas, see these presentations, start to develop ideas, and then have an opportunity to come back and interact directly with points of contact. And last but not least, if you still feel like you need additional engagement, it would be engaging with the NEUP office so that we can get you in contact with federal points of contact and make sure your questions are answered. So I hope that that gives an environment, of really, trying to define, what the programs are doing, what the potential gaps are, and otherwise to have an open format conversation in that regard. So I think that set of resources is intended to accomplish that goal.
For the final question, all of our resources from the webinar will be posted on the neup.gov website. It might be about a week or a week and a half when we get them all processed, and then you can find them there. They'll be in one of the announcements at the top of that page. So if you just watch for those will be posted and you can use them as you prepare your proposals. Hey, everybody, I think that's,
Maybe I'll just add a reminder for that link for anything that is related to ASI program. The link that was on the slide is asi.inl.gov. It will contain some of the information specifically pertaining to the ASI program, as well as a link to a sensor database, which is a public available database of sensors for nuclear application. It will, if you go through that link, it will take you there. It's a sensor is a database in which you have to provide, you have to register. It's just for identifying a person, right? So you just have to provide an email. There's no other needs, but if you go through the registration, then you'll be able to see essentially a list of sensors that should be able to provide a guidelines or an idea of the scope of the work in this space.
great. Thank you very much. Thank you to Patrick and to Becky for being here for the presentations, and for Melissa for being on the line for questions. And that concludes this session.